this video, I want to talk about the composition of two functions. So when we have a function, I think I've talked before about the idea that it's like a machine. You put in an input, so you put in your x, it does whatever it does to it. Maybe it squares it, maybe it adds 3, maybe it takes its square root and subtracts 4 and divides by 2. Whatever it does all that stuff, and then it puts out some other thing. So a composition of functions is basically just when instead of just putting an input into a function, we're putting an input into one function first and then straight into another function. So if we have a g function and we put the input into the g function, but then the g function spits it right out and puts it right into the f function, this is what's known as a composition of functions. It just means that we're putting our input into one function and then straight from there into another function. So the notation for composition of functions can be a little bit confusing, but basically we start out, you kind of work backwards. So start with your x. Let me actually do a different color for my x. So start with your x. And then if we're doing the g function first, we would say, okay, so we have g of x. And then we would say, okay, so now we want to do f of x to that. So it would be f of g of x. Now, mathematicians are lazy, and they decided that they wanted to shorten this notation. And so a lot of times you're going to see it written as f with a small circle and then a g of x. And the small circle just means of, so f of g of x is how we would read it. And don't ask me why this notation is too much to write and this one's better. I'm not really sure. But if you ever get confused about what we're talking about, go back to the extra set of parentheses. So we're taking the x, we're putting it into the g function first. Then whatever we get out there, we're putting it into the f function, which is exactly what's happening here. So we're taking our x, we're putting it into the g function. Whatever comes out of this is going to be g of x. And that falls right into the f function. And whatever comes out of that is what we call f of g of x. Okay, so let's go ahead and give some example functions here and see what we can do. So let's say that f of x is equal to 3x minus 4, and let's say that g of x is equal to x over 2. All right. Now, if we want to find what's f of g of x, so find f of g of x, then we're going to take the thing that happens first. So the thing that happens closest to the x first. So we're going to take x over 2, and then we're going to put that into the f function. So the f function is 3 times the input minus 4. So it's going to be 3 times the input minus 4. So it will become 3x over 2 minus 4. And that is f of g of x. Now, we could also find it in the reverse order. What if we put it into the f function first and then the g function? So we would write that g of f of x. So in this case, we would take the f function first, which is 3x minus 4, And now we're going to do the g function to it. So the g function is input divided by 2. So this would give us 3x over 2 minus 4 over 2 is just 2. So you can see that these are different. They're not going to be the same depending on the order that you do them in. Different functions will be more or less different. These are not so different, but they are different. So be careful. Make sure that you're doing it in the right order. Make sure that the function that's closest to the x gets done first. And you can think about this picture when you're doing it. So the x goes into that first function, and then it goes into the second function, and we sort of write it from inside out. And that's how you find the composition of two functions.